Video I'll be explaining the textbook problems of both composite and as well as implicit functions. So now let's discuss what is an implicit function and how to just differentiate that and what are the mistakes you people normally commit in this. Let's go with that. So first of all, I just basically in what is called functions, I've explained in detail about the domain, range, and after that I just went into the what is called dependent, independent, and everything. So the definition goes something like this: a function expressed in the form of f of x comma y, some constants you see, that's called as implicit. We just define this as implicit. So what is that f of x comma y? See, whenever I write f of x, it simply denotes that we have a function and in that we have a variable x. That's a simple information which f of x gives to you. In the same way, if I just write g of y, nothing wrong if you write f of y as I have taken f, so just I have taken g of y there. If I write g of y, it indicates that the whole expression it has got a variable, say y, that's it. Say if I write x plus sine x, this is a function. This is a function, and you can observe the variable what you have is x. So therefore I just write this as f of x. When I have something like y square plus 2y plus 1, so this is a function in terms of y. In the sense, it has got a variable y. So therefore I define this as g of y. Nothing wrong if you just write f of y. So now what is this f of x comma y? F of x comma y indicates a function has got both the variables x and as well as y. So when the function has both the variables in it, simple like x plus y plus sine x, it has got both the variables like x variable and as well as y variable. So just such a function is defined something like f of x comma y. If I write something like x square plus xy plus log x equal to something like a. So you can observe this whole function, it has got a variable x and as well as y. It's like agreement of both x and y. So we define this as what is called implicit function. Now in this session we'll be knowing how to differentiate implicit functions. So let's go with this. I think explicit is something like very clearly x and y are at the different phases, like when you have something like y is equal to x square plus 2x plus 1, this is an explicit form. So now we'll be discussing or we'll be focusing mainly on what is called implicit functions. So when a function is given something like x plus y is equal to pi, or x plus y is equals to anything, any constant, say 100. Okay. So this you need to observe. We have a function in terms of both x and y, and you may have a question like, so is there any possibility of converting this to explicit? Yes, for few functions you can convert. So now I can write this as something like y is equal to 100 minus x. Now this is y equals to, this is a function in terms of x, I can write this as f of x. So now this is the explicit form. So few implicit functions, this is implicit initially. Few implicit functions you can express this in explicit form, then you can differentiate. That's one way. So now let us just point out to an implicit form only. Now if the question is like x plus y is equal to 100, find dy by dx. That's the question. So find dy by dx and it is understood that we have to differentiate the function with respect to x. So as in the initially, like in the first video, I have explained about what is the complete concept about the differentiability the dependent and independent variable, everything. So now it is understood we have to differentiate with respect to x. So now differentiating with respect to x. Differentiation of x with respect to x is 1 plus differentiation of y with respect to x is dy by dx, and differentiation of constant is 0. So that is dy by dx becomes minus 1. The common mistake what people commit is, so let us take this example. Even though you have a variable called y, again you have a practice of taking something like y is equal to x plus y. So where is the necessity in taking again y there? You have the mixture of both dependent and independent quantity x and y there. So when the question is like find the derivative, find dy by dx, it is understood that the dependent and independent are y and x. So in the sense you need to differentiate this whole thing with respect to x. It's understood. So again there is no possibility, like you are not supposed to take that as y equals to again. So this is a simple problem I taken, and let's go with a few more examples. X square plus xy plus y equal to 1. So find dy by dx is the question. So let's differentiate with respect to x. Differentiation of x square is 2x plus x into y. Remember, this is a fundamental thing, and even in the first year we had this concept. Whenever we have product of two functions, sin x the product of x you have x and y idaga product only ನೆನಪಾಗಲ್ಲ. sin x into cos x ಇದ್ದಾಗ ಅಷ್ಟೇ ನೆನಪಾಗ್ತದೆ, because you have that urge that only you have to use that u into v for all those sin x into cos x, tan x into secant x ಇದಕ್ಕೆ ಮಾತ್ರ ಯೂಸ್ ಮಾಡಬೇಕು ಅನ್ನೋ ಒಂದು ಇಂಟೆನ್ಷನ್ ಬಹಳ ಡೆವಲಪ್ ಆಗಿದೆ. So it's like we have to use product rule whenever we have variable into variable. Very simple. Function into function. When you have 2 into sin x, no need of using u into v rule, because 2 is a constant, sin x is a variable. No need of using, see, it doesn't mean that u into v, 2 sin x, u into v use ಮಾಡಿದ್ರೆ it is wrong ಅಂತ ಏನಿಲ್ಲ. Suppose if you have a function like y is equal to 2 sin x, maybe over practice ಅಲ್ಲಿ, not over practice, ಅದೇ ಗುಂಗಲ್ಲಿ u into v ಗುಂಗಲ್ಲಿ ಇಟ್ಕೊಂಡು I'm going to use u into v here. This is u, this is v. Nothing wrong, but it is like stupid. Simple adana why you are making it is a very complex thing. Like 2 v dash differentiation of sin x is cos x plus v u dash differentiation of constant is 0. 0 into something is 0. So the left part is 2 into cos x. But whenever we have constant into some function, it is better to keep the constant as it is and differentiate the function. That's a simple way. It's complex. Complex in the sense one step back extend ಮಾಡ್ಕೊಂತಿದ್ದೀರಾ. Directly can write dy by dx equals to constant into function. Whenever we have constant into function, keep the constant and differentiate the function. 2 into differentiation of sin x is cos x. That's it. So the problem comes when you have variable into variable, sin x into cos x, you have to use what is called product rule. You had that in first year. So u v dash plus v u dash, keeping the first function as it is, differentiate the second, plus keep the second function as it is, differentiate the first. Simple. So now just look at this expression. We have xy. xy in the sense x is variable, y is variable. So product of two variables. So we have to use uv rule. Remember, you are differentiating with respect to x. So now you can choose anything. Like there is no priority here. So u into, I'll take this as u and this as v. U into v dash. Differentiation of y with respect to x is dy by dx plus u into v dash plus v into u dash. Differentiation of x with respect to x is 1 plus differentiation of y with respect to x is dy by dx equals to differentiation of a constant is 0. So in implicit functions you have to remember one thing: identifying the variables. Whenever there is a product of two variables, use uv rule and keep all dy by dx terms at one side and the left to the RHS, just send to the RHS and take common, finally we'll be getting dy by dx. So now you have this expression which has a dy by dx term there, and even this one, just keep this as it is, x into dy by dx plus dy by dx, that is equals to, so just send this to the RHS part, so it becomes minus 2x and this is minus y. So take common, dy by dx common, so you'll be getting x plus 1, that is equals to minus, you can take minus common, or if you feel that this is very complex, if they are complex and transporter, just leave. So minus of 2x plus y. So there is no rule that you minus common ತೆಗಿಲೇಬೇಕಂತಲ್ಲ. Minus common ತಗೊಂಡ್ರೆ it indicates that you know a little bit of basics of the artha. Now dy by dx is equals to, it will become minus 2x plus y divided by x plus 1. That's it. This is the derivative. So only thing is that where the students commit mistake is in the initial step itself. Starting a y is equal to the whole thing will collapse. That's a first big mistake. The second is you need to have that sense, like differentiation of y with respect to x is dy by dx as proper. The third is like you'll just struck here after differentiating. Just remember, when you have multiple dy by dx, just group them and take out common. That's a very simple common sense. That's what I've done here. So taking dy by dx at one side and non dy by dx term to the right hand side, and finally getting that expression dy by dx. So this is how you need to differentiate. So you know the concept. The thing is, when we have some problems, maybe some trigonometric, then the problem arises. So let's go with one more. Find dy by dx. If sin square x plus cos square y equals to 1. So in the last previous video, I just said when to use x power n. That's what I've explained. When to use x power n. X power n yavar use madabeku. We have to use x power n whenever we have a function of the form x cube x square alla. Variable to the power of constant. Whenever you find a variable to the power of constant, you simply use x power n. That's it. Clear? So variable to the power of constant is again madabeku. Just I think in the previous video I explained this. D by dx of variable to the power of constant. Keep that constant. Reduce the power of the variable by 1, c minus 1, and differentiate the variable d by dx of v. This is how you need to differentiate. Suppose when you have variable plus x is there, you simply write x cube. Just write differentiation of x cube, 3 into x to the power of 3 minus 1. That's all. When you have anything apart from x, maybe sin x, log x, or anything, just remember this. Write the constant, reduce the power of the variable by 1, then differentiate the variable. So this is a simple thing you should remember. So I've taken a problem like sin square x plus cos square y equals to 1. Remember, this is an implicit function. Again, no need of taking this as y equals to. Clear? So now this can be written as sin x whole square plus cos y whole square equal to 1. So note down this, sin x is a variable, 2 is a constant. How do you differentiate this? 2 into sin x whole to the power of 2 minus 1. Right, the constant, reduce the power of the variable by 1, then differentiate the variable. Differentiation of sin x is cos x plus the same thing, cos y whole square, the same thing. So 2 into, reduce the power of the variable by 1, 2 minus 1 into differentiate cos y. Differentiation of cos y is what? Minus sin y, and we have something, and let me explain that. Pause martini, because you need to know how to know the differentiation of sin y, cos y. Very important. Remember sin x. Now I am differentiating with respect to x. If the question is find dy by dx, it means that we have to differentiate with respect to x. So when you are differentiating with respect to x, differentiation of sin x with respect to x is cos x. Just remember this very simple point. When you are differentiating with respect to x, functionally x irbeku. That's a very simple thing. X ಬಿಟ್ಟು y ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ ಅದನ್ನ ಮಾತ್ರ differentiate ಮಾಡಬೇಕು. That's a very simple thing. Now the question is find dy by dx. So which indicates that we have to differentiate the given function with respect to x. Means we need to have a variable x. So now what is differentiation of sin x cos x? So variable x is as it is ಬರ್ದಿದ್ದೀನಿ. Instead when you have something like sin y, now the question is find dy by dx. Means we have to differentiate with respect to x. When you are differentiating with respect to x, x ಬಿಟ್ಟು ಬೇರೆ ಏನಾದರೂ ಇದ್ರೂ you should again differentiate. That becomes complex. So now what is differentiation of sin y cos y into you are differentiating with respect to x. When you are differentiating with respect to x, variable x ಇರಬೇಕು, but we have y. Means x ಬಿಟ್ಟು ಬೇರೆ ಏನಾದರೂ ಇದ್ರೆ ಅದನ್ನ as it is ಬರೋದು, ಅದನ್ನ ಮತ್ತೆ differentiate ಮಾಡಬೇಕು ಅನ್ನೋದು ನಾನು ನಿಮಗೆ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. If you have anything apart from x, write that as it is, then differentiate that. ಈಗ ನೋಡ್ರಿ, when you are differentiating with respect to x, you need to have x, but x ಇಲ್ಲ ಇಲ್ಲಿ, you don't have x here. Therefore keep that variable as it is. Differentiation of sin y is cos y, and finally differentiation of y with respect to x is dy by dx. This is very simple and important. This is the area where you'll be committing a lot of mistakes. So let me just explain few problems, then I'll get into this. Sine of x square. Just remember one thing, when you are differentiating with respect to x, we need to have the variable x. Instead, just listen this carefully. When you are differentiating with respect to x, you need to have the variable x. Instead, when you have anything apart from x, maybe x square, maybe 2x, maybe something log x, maybe sin x, maybe x square, keep that as it is, then you differentiate that. This is a very important thing. Now, differentiation of sine of x square is cos of x square into, we don't have x here, instead we have x square, therefore you have to differentiate that. Differentiation of x square is 2x. Same thing, sine of e power x. I think in the last video I discussed all these problems. Differentiation of sine of e power x is cos of e power x, and differentiation of e power x is e power x. In the same way, when you have something like sine of y square, differentiation of sine of y square is cos of y square. Remember this mantra, when you have anything apart from x, when you have anything apart from x, when you have anything apart from x, x ಬಿಟ್ಟು ಬೇರೆ ಏನಾದರೂ ಇದ್ರೆ, keep that as it is, keep that as it is, then you differentiate that. That's a very simple thing. Let me go with sin y first. I'm y square of sin y. Differentiation of sin y is cos y. So variable y is as it is ಬರ್ದಿದ್ದೀನಿ. So again let's differentiate that. Differentiation of y with respect to x is what? dy by dx. So still let me get into few more simple examples. Adhaadmele we'll take up this. What is derivative of y with respect to x? That is dy by dx. That's simple. Differentiation of y with respect to x is dy by dx. Let me take y square. Y square. Y is a variable and this 2 is a constant. Y is a variable and 2 is a constant. Now this is variable to the power of constant. So that's a wrong notion, like we have to use x power n only for x power 3, x power 2 ಅನ್ನೋದು x power n ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕಂದ್ರೆ ವೇರಿಯಬಲ್ ಟು ದ ಪವರ್ ಆಫ್ ಕಾನ್ಸ್ಟೆಂಟ್. ವೇರಿಯಬಲ್ ಅಂತಂದ್ರೆ ಸುಡುಗಾಡ್ ವೇರಿಯಬಲ್ ಇರಲಿ, ಮೇ ಬಿ x, y, sin x, log x ಏನರ ಇರಲ್ಲ. So in the place of variable I have y there. So in the constant 2 ಅಲ್ಲ. So variable to the power of constant. Which formula I have to use? X power n. Differentiation of x power n is n into x to the power of n minus 1. That is n into x to the power of n minus 1. Apply that mantra. What is that? If you have anything apart from x, differentiate that. X is live. So n into x to the power of n minus 1 use ಮಾಡಿದ್ಯಾ? ಅದಲ್ಲ, variable to the power of constant. Keep that constant, reduce the power of that variable by 1, then differentiate the variable. Same thing. Keep that constant, reduce the power of the variable by 1 and differentiate the variable. Differentiation of y with respect to x is dy by dx. So that is a very important and fundamental thing you have to remember. Let's go with CL. Y cube, differentiation of y cube with respect to x. Keep that constant, reduce the power of the variable by 1 and differentiate the y. Differentiation of y with respect to x is dy by dx. That's it. This is how you need to differentiate. Okay. So in the same way, differentiation of cos of y square. Differentiation of cos of y square is minus sine of y square. Inner part, y square. Differentiation of y square is 2y into dy by dx. So this is the core idea. So now let me just explain it once again. So sine square x plus cos square y equal to 1. This is the problem. So this is sin x whole square plus cos y whole square equal to 1. Sin x is a variable, 2 is a constant, a variable to the power of constant. Write the constant, reduce the 2 into sin x whole to the power of 2 minus 1. Differentiation of sin x is cos x plus the same thing, variable to the power of constant, set it constant, reduce the power of the variable by 1, then differentiation of y with respect to x is dy by dx equal to differentiation of constant is 0. This is the area where you will be committing mistake. So in concentration layer again not is equal to 1, but the whole thing gone. So now this is 2 sin x cos x. This is, I'm sorry, differentiation of cos y is minus sin y into differentiation of y with respect to x is dy by dx equal to 0. So now we have plus into minus is minus 2 cos y sin y into dy by dx equal to 0. So 2 sin x cos x is sin 2x minus 2 sin y cos y is sin 2y into dy by dx equal to 0. So finally, so just take this to the right hand side. So we'll be getting sin 2y into dy by dx equal to sin 2x. Finally, dy by dx is sin 2x by sin 2y. So that will be the result. So in this implicit functions, you have to be very clear with the variable and composite differentiation. That's what y square composite differentiation clarity. That's very important. So let's take up one more problem. Sin xy plus y equal to x. Sin xy plus y equals to x. I have taken few examples and I am doing in the next video. So I will be just explaining the textbook problems. The question is find dy by dx, means you have to differentiate the whole thing with respect to x. So now remember, sine of something. What is differentiation of sine of something? Cos of something. In the sense, differentiation of sine x is cos of xy into inner part. Inner part is xy. Just now I said if you have anything apart from x, you have to differentiate that. In the x on the xy. So therefore inner part I have to differentiate. So now xy, how to differentiate xy? X is a variable, y is a variable, variable into variable. So you use product rule. That is u into v dash. Differentiation of y with respect to x is dy by dx plus y into differentiation of x with respect to x is 1. U into v dash plus v into u dash plus differentiation of y with respect to x is dy by dx is equals to differentiation of x with respect to x is 1. So once again I'm just repeating this part. Sine of x. Let me just take out few problems, few simple, and then feed into this. Differentiation of sine x is cos x. In the same way, sine y. Differentiation of sine y is cos y. Inner part x is now. You don't have x. Look what you have there instead of x, y. Therefore differentiate that. Differentiation of sine y is keep that as it is. Then differentiate. Differentiation of y with respect to x is dy by dx. So in the same way, sine of y square. Differentiation of sine of y square is cos of y square, and inner part y square. Differentiation of y square is 2y into dy by dx. So now in the same way you have something called sine of xy. Differentiation of sine of xy is cos of xy. Inner part xy. At inner ಒಳಗಡೆ xy ಇದೆ. U into v. That is u into v dash plus v into u dash. That is what I have written here. So this step is clear, and differentiation of y with respect to x is dy by dx. Differentiation of x is 1. First let me multiply x into cos xy into dy by dx plus y into cos xy plus dy by dx equal to 1. Product is there. First you multiply, then normal in common given the normal. So I multiplied this. Okay, now this is an expression containing dy by dx term. This would have just keep that to the LHS part. X into cos of xy into dy by dx plus dy by dx equal to 1. So just send this. This is not dy by dx term. Akkadiki send maadu. 1 minus y into cos of xy. So finally what is common? Dy by dx is common term. So we are getting x cos of xy plus 1 equal to 1 minus y cos of xy, and send this to the denominator. So there we will be getting what is called dy by dx. So in this video, so I've just explained about so few problems. Maybe the stress it must be given on something like y square, sine y, sine of xy, cos y. So you need to practice these as much as possible. So this is about the implicit functions. I've just given the cream layer of it. In the next video, we'll be just merging out the composite and as well as implicit problems. Not exactly the textbook one. We'll try to solve the additional problems. We'll get from example and also. So we'll solve some 20 to 30 problems in the next class, so that it will be very easy for you to get into the exercise part. So in the next video we'll have the session will be on exclusively on problems on composite and implicit functions. This is just a fundamental thing. Thank you.